Are we ready? Ready? Okay, so the next tool we are going to be studying is the ISO 14001. And before we do that, there has been a heritage of different standards which have been put forward for different reasons, And I want to preface this by asking you, why do companies pursue standards? In fact, let me ask you a simpler question. You as individuals, your students, right? Your students, and you pursue a degree. So everybody gets like a BE, an MTech and all that, right? But over and above that, you can also pursue certifications. What are some examples of certifications? No, you as in, yeah, you can do individual Six Sigma training too. Yeah, that's a good one. Like blue belt, black belt, green belt. What else is there? Cost management, process management, PMP. Okay, chartered accountant. I used to be a chartered accountant, right? Cost management. DBA. What does that stand for? Okay, database administrator. You can get a certification in that. CMMI. All those certifications are there. Java certifications, right? Why do people pursue those certifications? Huh? And also applied knowledge, right? Many of these like Six Sigma and all that, you have to do a project. Am I right? What about the company? Let's take the company case. Why do they pursue certification? Pardon? To maintain quality? That would be just the first one. ISO 9000. Why do they pursue all these certifications in general? Customer satisfaction. Huh? Reputation. Okay? Reputation. Actually, you answered both the things that I wanted. One is, so it's a signaling thing. It's a signaling to multiple stakeholders. It is not just the customers. Okay? Now, but what you said brought about another thing I should have added to this as well, which is called buyer certification. It's relatively rare, but you may pursue for a customized buyer certification, and along the same lines, buyer awards. So many companies give best supplier award, most supplier, the supplier who gives the most suggestions. So all variations of things, right? So it is to meet customer satisfaction, it's to give a signaling. So if I go abroad, if I I go abroad to select my suppliers, if they have these certifications, it's a signal for quality. It's a signal for environmental certification. Okay? Now, before I go through all of this, should a company pursue all these standards? Or how do they choose which standards to pursue? Based on the production. But many of these do have their service equivalent also. ISO 9000 for manufacturing, 9001 I think is for services. Many of them have the service requirement as well. So after some time, especially on the environmental one, look at how many are there, right? And I have not even hit the tip of the iceberg over here. There's more things that you can probably add to this, okay? But historically, I talked to you, remember, the quality, lean, environmental movement, right? So all of them had certifications attached to it. ISO 9000 was the first quality certification, which is given by the International Standard Organization, the same one which does ISO 14000 as well. Okay. Now, just like as a requirement to buyer, there can be industry certification. And I see a pattern here, industry awards also. So an example of industry certification is QS 9000 for the auto industry. And an example of an industry award is the Best Plant Award given by Industry Week. Okay, they give the Best Plant Award and so on, right? So you can either pursue a you can pursue an award. Which is better? Awards are better? Certification. The pattern that it's mixed tells you what the answer is. Okay? Some people think that, for example, some of these awards, to apply for these awards is really expensive. It requires external people to come and examine. The same thing is for ISO 2. Some people may find it better to apply for the Best Plant Award, and they can put a nice little flag on that plant, and then suppliers and customers come and see. They say, "Oh, this is a good plant." Okay, so US 9000 was a standard floated by the auto industry, the big three of autos, GM, Ford, and Chrysler. Okay, in terms of quality awards, there are numerous of them. The most famous was called the Malcolm Baldrige National Quality Award, which was given by the Department of Commerce. One good thing which happened from the quality award is that there was this gap between the Japanese quality, especially in the car industry, and the US car quality. And this gap, the process of understanding that framework, even if you didn't apply for the award, you understood a framework of which 7 or 8 things depict very good quality. And people use that as an audit tool. How good are we doing in process management, in leadership, in customer satisfaction, in business results? So this framework itself allowed them to become better in quality. So this was an undesired outcome which came out of this, that because of the quality process, the US company's quality also improved. Okay? In Europe, they have a European Foundation Excellence in Management or something like that. I think the EFQM, European Foundation Quality Management or something. And there are innumerable state quality awards. And the subject for today is ISO 14000, which certifies environmental excellence. Okay. Now, along with it, in fact, they are linked to each other. Some companies may only deploy environmental management systems rather than pursuing a certification or an award. There is also a certification for safety. There are awards given for safety as well. Then closer to our home, we have to take into account ROHS, the restriction of hazardous substances. CIRCLA, this is dealing with site pollution and hazardous substances. So this law will tell you what you should do and what you cannot do. And then IEEE, if you want to go into electronics, for computers and monitors alone, there's IEEE 1680. And we all talked about LEED certification. This is the green building standard. So, this is a handful of so many certifications out there, and you may get into certain industries or contexts where there might be new, or certain countries may require you to pursue some certifications as a screening mechanism. So what is the ISO 14001? It is an internationally agreed standard by ISO that sets out the requirement for what is part of a good environmental management system. Okay? So if organizations improve this is where the lean and green comes. That in the process of doing lean management, if I also look at the green part of it, then I can optimize not only the lean results, which is cost, quality, lead time, flexibility, and so on, but I also can get better on the green part. Efficient use of resources, reduction of waste, and then also gaining a competitive advantage and trust of the stakeholders. So what is an environmental management system? It helps organization identify, manage, monitor, and control their environmental issues in a holistic manner. Like the TQM and the Malcolm Baldrige Quality National Quality Award, it's a set of subheadings that you can look at. You can do the same thing in terms of adopting these as is, and then tailoring some of your own as well. I'll tell you what the high-level structure is in a minute. Like other ISO management systems, it comes with a high-level structure, and it could be I told you the audit tool. It can be used for continuous improvement, not only on the lean, but also on the green and the environmental outcomes. So who is ISO 14001 for? It's suitable for organizations of all kinds, government, non-profit, profit, private, right? It requires an organization to look at all the environmental issues in all kinds of its operations, such as air pollution, water and sewage issues, waste management, soil contamination, climate change mitigation, and adaptation and resource use and efficiency. Very quickly, you get into the public domain of that. It's not only you as a company, but where you reside in the community, because a lot of these things like wastewater, air pollution, sewage issues will also transcend into the surroundings and the community too, you know. So you don't exist as an isolated silo. So you can't say, I sit as an organization, I can pollute as I will, and I can, you know, let my wastewater drain anywhere else, and I don't have a very good system of taking care of my toxic chemicals and so on. And so this is not only making an environmental impact, but it can help you in your green as well. The latest standard of ISO 14001 is the one floated in 2015, and it was revised to incorporate these three things which I have put in italics. Okay, the increased prominence of environmental management infused into the strategic planning process. Okay, it helps you make the connection between the environmental strategy and top management strategy. A greater input from the leadership. Okay, so all of these criteria, by the way, have sub-criteria, so that can be used like a survey and audit checklist and so on, right? A stronger commitment to proactive initiatives rather than reactive initiatives that boost environmental performance. And the little later on, I'll tell you how often they revise this standards. So who benefits? What benefits will come if I adopt this ISO 14001? It will show compliance. You'll have to do this anyway. Compliance with current and future statutory and regulatory requirements. It will improve your leadership involvement, engagement with your employees, as we have seen in many cases in this course, right? It improves the company reputation, also something we have seen in this course, and confidence of the stakeholders through strategic communication. And the other thing from an operational point of view is that it will align strategic business units with your top management strategy, corporate strategy with the functional strategy, by looking at the environmental issue. It will provide a competitive and financial advantage through improved efficiencies, lower costs, and so on. And from a supply chain point of view, if you do something well, then you can prompt, encourage, stimulate your suppliers to do the same thing well. I always, when you do your projects, also please think of this like this, that when you study a focal company, you have a mirror company. If it's a very extended supply chain, you have a mirror company in the customer side as well. But if your customer is the end consumer, okay, and you are studying some issues, environmental issues, renewable energy issues, some supply chain issues, bear in mind that you have a parallel supplier factory out there who's running the same operations. It's just that it's a part to your company, but for them it's a finished goods. So everything that you do, they do too. Everything that you introduce, you should try to introduce that with your supplier. All the things I put in the slide, quality first, then I said safety, environmental health and safety, ISO 14001, EMS, right? First you got to do it right. And then you can tell your suppliers that, you know, why don't you also do this right, like safety and all that, and then integrate them with the supply chain and organization's business system, okay? Now this is the part of the upgrades, like why do they keep revising the standards? They're always reviewed to make sure they're relevant to the marketplace. So for example, the latest trends was to factor in external and internal elements like climate volatility, competitive context in which they work. So they started adding these elements into it. And the changes also ensure that the standard is compatible with other management standards. This is the hierarchy, which I will show you in a minute. So it is consistent with the other management standards in place as well. So right now, for you to get ISO 14001 certified, you have to show that environmental management is a key part of your strategy. You have to show a greater commitment from leadership. You have to show that you have been proactive on environmental issues to prevent it from harm from the environment to degrade and prevent any harm in the environment. Focus on life cycle too, right? We saw a little bit of that yesterday. We're going to talk about that here today as well. To consider the environment from development to the end of life, okay? And the addition of you have to communicate with your stakeholders. This is what we are doing on our EMS or an environmental management system. By using the same terminology, same structure, which is subheadings and so on, it has seamlessly fit with the hierarchy of ISO 14001 standards. What does this mean for you? ISO itself does not certify. So you have to employ a third-party certifier to do it. And once you get certified, there's a 3-year, by the way, this is true for all certifications. You know, I'm certified in CPSM, which is a purchasing and supply management one, and every 3 or 4 years, you know, I have to show continuous development, and then I get recertified for that, right? So you're given a 3-year transition period, and once the revision has been published to migrate to the new standard, and after this period is done, the third party, you can do it by third-party certification, and you will seek certification on the new version. It's like this. I've always been a victim of this. Every time when I was in 10th standard, they changed the syllabus. We had from old math, it went to new math. I went to 12th, they did the same thing. So every time we have this practice in education where we change the syllabus, right? And it's called something old and something else new, usually very tough ones, you know. And so that has been, so that's what they're trying to do. Should I be certified to ISO in ISO 14001? You have a choice. You can do EMS or you could do certification. It's not a requirement. But when you do a third-party certification, it gives you much more transparency and validity because there's no bias in it. Okay? And for some organizations, it helps you meet, you know, regulatory or contractual agreements. As I told you, ISO does not perform certifications. You have to get it certified from third-party ones, right? The examples, and I'll give you 2 case studies about this in a minute. Examples of success with ISO 14001 is they have found success in a wide range of areas: reduced energy, reduced water consumption, a more systematic approach to legal compliance, and an improved overall environmental performance. You see a mix of reactive and proactive stances over here. Okay, 2 case studies. One is a British case study. So they found by going and getting certified with ISO 14001, they had big improvements in the recycling rate. Okay, we have been a zero landfill since March 2013, and are recycling and reusing 100% of our site waste. We have continued to improve our relationship with our neighbors. So this is a community engagement because we have processes in place to respond quickly to any concerns. In this day and age, if anything can go wrong, it will go wrong. If you look at the tsunami thing, Katrina, Hurricane, and all that. So you have to be aware. So they talk about business continuity decisions. What do you do if a natural disaster occurs, right? Among other things, like the chronicles, remember the footprint chronicles? Among other things, our processes, our benefits are the processes and the appointment of the Green Matters champion. So like the footprint chronicles, they have a structure in place to make sure that they're, you know, recording all the environmental success stories, they're engaging with them and looking at the site's potential impact on the environment. Let's switch to a Japanese company. This is Upcon, and they're in the business of, it's a very complicated business, by the way. They're in a service business to lift up sunken concrete floors, and they've patented this process called the Upcon method. And achieving certification allowed us to document effectively the details of our method to the staff, to share and standardize the quality of work at the site. Okay? In addition to this, it helped you in quality control, demonstrating carbon footprint. This is what we're going to get to next. 90% less carbon dioxide emissions, and with that, staff got engaged more, they got motivated more, and they contributed positively to the, you know, to being environmentally friendly in terms of products and processes. So there are innumerable stories like this of ISO 14001 certification. The process works like this. You define your objectives, what do you want to do with the standards, get buy-in from senior management. It's important to get organizational support from the leaders, get a good overview of existing processes and systems relevant to your environmental impact. In your projects, I would like you to do this as well, the before and after in terms of the environmental impact. Now you will have so many tools at your disposal to be able to do that. Okay? This is the hierarchy that we were talking about. So in the hierarchy of the ISO 14001, we've been talking about 14004, which is the establishment, implementation, maintenance, and improvement of the EMS. But if you want to look at eco-design, Then the ISO, that is the ISO, there's a separate set of guidelines on eco-design for 14006. And if you want to look at the subject next for today, which is greenhouse gas emissions and removal, quantifying and reporting that, then you have a separate standard called 14064-1. So that's the hierarchy of standards. Anything on ISO 14000 or certification in general before we go to carbon footprint? Any questions, comments? International would be better. And again, if we can't think of any company which is national, having only national customers and having only national suppliers. So if you have to go abroad, which most companies do, and even if you're a small and medium enterprise, you have to be supplied, you have to be certified internationally. I did some work with a company in Bombay, a family-owned company, who was a supplier to Hyundai here in Chennai. And they were certified all the time by quality. Hyundai will certify on this standard. So they stood to lose business if they didn't get certified. All right, carbon footprint analysis. So you all read the handout. So I want to pinpoint some of the key parts of that particular handout. And so the process, thankfully for us, and maybe this is a good tool for you in your projects, that you can follow the greenhouse gas protocol in your projects. Okay? In the greenhouse gas protocol, you determine first organizational boundaries, which means which elements comprise the company, which elements are indirect to the company. The second one is the operational boundaries. Okay? Direct sources would be sources owned and controlled by the company. Examples of that will be boilers, furnace, vehicles, and other production processes. Indirect sources are sources not directly owned or controlled by the company, but it's influenced by its actions. How are they influenced? Most common one is electricity purchased from utility. The other one is employee commuting. Very difficult to track, by the way. Okay? Emissions generated by suppliers. Somewhat easy, but it can be tricky. Okay? Activities from customer use of products and services. Now, this is a supply chain wide view of your greenhouse gas. So, the requirement of the project is the supply chain wide to the extent that you can go. Why not use this protocol? And why not make an attempt at this particular protocol to draw the organizational boundaries, draw the operational boundaries, find the direct sources, and find the indirect sources. Okay. The next step is to track emissions over time, for which you have to compare against a base year and establish an accounting cycle. How often are you going to do it, and what other ways are you going to track emission over time? Collect data. A lot of assumptions are based on that data, and still we have a lot of tables that we can use to our benefit, and then calculate the emissions. The protocol provides specific guidance on how to collect source data. And in the handout, you have several exhibits. I'll pinpoint a little bit of that over here, and this is considered to be established standards of conversion. Okay? And how to calculate, finally, how to calculate the emissions of greenhouse gas. So, the calculation of a greenhouse gas effect is a process that differs depending on the emission source. Generally, a consumption quantity, either fuel and electricity, is multiplied by a series of source-specific emissions factors, and that's where the tables come in. And to estimate the quantity of each GHG produced by the source. Usually, it is 1 unit of that particular combustion source, which is converted into CO2. That's how they do the emissions factor. So, each emissions factor is a measure of average amount of a given greenhouse gas reported in weight when combusting 1 unit of the source. Okay? For example, a gallon of gasoline produces an average of 8.79 kg of CO2 when combusted in a car. Because multiple GHGs are measured in the inventory process, the accounting process calculates the emission for each type of gas. For each type of gas. Okay? So, as a common practice, emissions of non-CO2 is converted into CO2 equivalent, okay, to facilitate the streamlining reporting of a single emissions number, which is CO2, which is the standard. In this conversion, the emissions total for a gas like methane, which is known to be 25 times more potent than CO2 in the atmosphere, gets a global warming potential conversion factor of 25. Okay? The methodology, and this is the most interesting part, whether you have, and I'll show you an example, whether you have a single facility or a single vehicle, or you have thousands of retail stores or long haul trucks, the calculation methodology is the same. Okay? And that's a useful task to know, because you can roll this out, you know, on a large scale. So we are going to start on a very small scale. Okay? Here's an example of an inventory process for a sole proprietorship. So this business owner is a skilled cabinet maker who manufactures and installs custom kitchen cabinets, bookshelves, and other high-end products for homes. She leases over several thousand square feet of a shop space in North Carolina, and owns one truck, a single gasoline-powered truck, which she uses to deliver products to the customers. Okay? So the business owner consults the same protocol that I'm asking you to do, the GHG protocol, and identifies, in her case, 3 emission sources. Her direct emission sources will be the truck that she owns, gasoline-powered truck, but she also uses natural gas. Number of natural gas-powered tools on the shop floor. And of course, she buys electricity. The indirect emission sources, electricity that the company purchases from a local utility on a monthly basis. Now, if you had to do a project on this, you have to collect data, you can mimic this process. So you can go and find out the accounts payable information. So you start with collecting the utility usage data, look for the accounts payable record for the past 12 months. So she's fixed the 12 months period, okay? And determine the quantities of fuel and electricity purchased. And their records, the accounting records reveal that she bought 26,700, now this is a mouthful, million British butane thermal units. Did I say it right? No, I missed something. 1 million British thermal gasoline, 115,400 kilowatt hours of electricity. That's a pretty high amount. Okay? The calculations for emissions for each source are shown in the next slide. So you start first with natural gas. For natural gas, you take the butane units and you multiply that by, depending on the type of greenhouse gas effect, the emission factor, global warming potential, and you get a kg of gas, right? When you do a project similar, you need to have these assumptions, okay? Some for which it's obvious, some you can go into the literature. As you saw in yesterday's presentation, we got a lot of that from the literature as well. The combustion of the natural gas emits all the 3 greenhouse gases, the most popular one, which is carbon dioxide, methane, and nitrous oxide. So we have the consumption of natural gas times the emission factor times the global warming potential gives you the kg CO2 equivalent, and you add this all from the source of natural gas. That's step 1. Then you do the same thing for vehicle gasoline. So the left-hand box replaces natural gas with gallons of gasoline. Then the rest remains the same, greenhouse gas emission, global warming potential, which is the kg of gas. In this case, the combustion of gasoline emits only 1 GHG, which is CO2. Okay? That's why you have only 1 row. All right? So this is the amount of, this should be gasoline, by the way. Emissions factor, global warming potential, so kg CO2 equivalent 21,579. So consumption of gasoline, so that heading is here. The consumption of gasoline, emission factor, global warming potential, and kg CO2 equivalent. Okay. Last is the indirect source. Indirect emissions from consumption of purchased electricity. The electricity paid for in kilowatt hours, and emissions factor is the same. Global warming potential is of gas. Now this is an assumption which I will show you in the table. Depends on the region from where the utility comes. In that particular region that the owner is doing business, it is assumed that the mix of the fuels used by the utilities will yield these 3 greenhouse gases, which is CO2, CH4, and N2O. There's nothing standard in this. In different regions, you may come up with a different combination of greenhouse gases. Okay. Again, consumption of, I made a mistake again. The heading is wrong. It should be consumption, okay, of electricity. Emissions factor, global warming potential, kg CO2 equivalent, which means now you get to the grand total. So the sum total kilogram emissions from all three sources represents the total annual for the business, subject to the boundary conditions we mentioned and assumptions defined in the exercise. The sum total is 1,094,747, okay, from all these sources. Now, let's look at the table, because the tables are very interesting. So this is standard that this 1 million British thermal units is a measure of energy content in fuel, normally used in power, steam generation, heat generation, air conditioning industries. 1 BTU is the equivalent of 1.06 joules in energy, and natural gas is usually measured in BTUs. You know the rest. You know methane, nitrous oxide, and carbon dioxide. Now, I tried to give you an excerpt of the table that you can use to get things like emission factors. So you look at the source, the emission source, natural gas, gasoline, and fuel oil. All of them have the same three GHGs in common: CO2, methane, and nitrous oxide. So the emission factors come from that thing, that average combustion that I told you. The starting unit is in the British thermal unit, and the ending unit is, of course, in kg CO2. Second thing is what happens. Oh, by the way, that was for stationary. The ones before this was for stationary combustion of fuels. And what happens for mobile combustion of fuels? These are all vehicles on the road. So you have gasoline cars, diesel cars, light trucks, medium trucks, heavy trucks, you know, and this is an excerpt, and even jet fuel, airline fuel, okay? The main GHG type for these types of mobile combustion thing is CO2, and the emission factors are given, which convert starting unit of gallons of consumption of that fuel into kg of CO2 as well. Now, this gets complicated now. Here, the case gives you the different regions of US, and I think the gentleman, I don't know if it was this guest speaker or the one before, that's the same thing which is possible in India also. So you have the different utilities, you know, in different states and so on, and I'm presuming they follow the same terminology. So it's called the grid, and they're given a E-grid acronym and a E-grid sub-region name, right? What is the grid which is supplying, for example, GRI would be a good example of what we are talking about, okay? So we have these three GHGs in the columns, and the conversion is from pounds of CO2, pounds to megawatt hours, okay? Pounds of CO2 emissions to megawatt hours. This is the conversion for each of these excerpts of purchased electricity from the different regions, okay? Last is the global warming potentials. It is the relative contribution amongst the harmful gases in terms of its potency in affecting the atmosphere. So in this case, you know, methane is 25 times more, and nitrous oxide is 298 times more harmful on that, right? This is helpful to you depending on the source unit and the desired conversion unit. So it just gives you, these days you have these tools on the web as well, the conversion between the starting unit and the target unit, including things like US tons, which is different from the other tons and so on, pounds to metric tons, kg to metric tons, a useful conversion table even for your projects as well, okay? Now, here is a practical application of this. Google is has one of the biggest carbon footprint on Earth, something which we may not have been thought of. The reason is that an average server has nearly the same carbon footprint as an SUV going 15 miles per gallon. It is estimated that it has over 500,000 servers alone and starting to grow significantly. And these huge data centers where the servers are residing are very huge. Look at the first one, 34,000 square feet. the other one 1,185, other one is smaller one 520, at least 5 new data centers that they are trying to build. I think it's probably already built, okay? And it has over 100,000 drives for storage. So if you go from the top data center, I mean the data center to a server to a drive, you can see the humongous multiplier effect on the carbon footprint, okay? So therefore, Google by far contributes to the most carbon emissions in the IT industry. It may even be the biggest carbon footprint on Earth. What they're doing is interesting too. I don't know if you've heard about this. This was new to me as well. Is that they're trying to do sea-powered data centers. And the way it works is that computing centers are located. By the way, they do a similar thing, although it may not help the carbon footprint, where to increase the bandwidth, they have mobile servers, which go around in cars, in minivans, in very congested places to boost up the bandwidth. The computing centers are located in ships, which are then anchored in a water body, and from which the energy with the natural motion of the water is captured and turned into electricity, and then the pumping power for the cooling pumps to carry heat away from the computers in the data center. And this is a very unique and innovative way for which Google has already got a patent, to reduce the carbon footprint. What else can we do to remove the CO2? Carbon means the reservoir of carbon is accumulated. It stores carbon for an indefined period, and the main sinks are the ones where it's absorbed in the ocean floor, or you can use biotic conversion, photosynthesis by plants and algae to turn the carbon into plant matter, or you can inject the CO2 emissions deep into the geological surface. So it is emerging in terms of how we can tackle this carbon footprint. Okay, I want to show you one more. I gave you a carbon footprint analysis predominantly from a company point of view. I want to give you an individual example, okay, to show what you can do even as an individual if you desire to do a carbon footprint analysis. This is pretty much a process diagram, which you will be doing for the project, by the way, for a newspaper manufacturing process. This is what is done to print a New York Times issue, okay? So from the left, you have fiber acquisition, then the paper is made, paper is transported to a printing mill, and from the left, the ink comes, it's transported, and the newspaper is printed, it is delivered, and then it is recycled. That is simply the process diagram for the printing process. Now, if I were to find out the carbon footprint which comes from one consumer trying to buy a New York Times subscription for a year, this is how I will calculate it. One economic activity of printing operation is converted to 0.546 kg of CO2. And this includes the upstream activity, which means from the left, the manufacture of the ink, and from the right, ink, and from the left, manufacturing of paper. To avoid double counting of the impact of paper manufacturing, we subtract that so that we don't add it both in the ink, paper, as well as in the printing process. 0.083 kg is removed, which leaves us with a net 0.463, which is clearly associated with the printing operations. Now let's find the global effect. If a weekly subscription of New York Times is $7.40, that means a year subscription is 740 times 52, which is 385. And assuming the distribution cost is another assumption, is 30% of that, then the economic activity for the printer, because we took manufacturing separately, is 70% of 385, which is 270. Therefore, printing operations and its upstream activities, except manufacturing, paper manufacturing, results in 125 kg of CO2. That is the 270 which we got in the previous one times that 0.473, which is the net effect of 0.473. So we found the carbon footprint for printing. Now we move to distribution. What we are assuming here is that the newspaper is sold in Berkeley, California, and it is printed 2 kilometers in a place called Concord. The emission factors for heavy good vehicles, which is used to transport newspaper, is 0.12631 kg CO2 equivalent per ton kilometers. Okay. So 236 kg of newspaper, that's the yearly subscription, which converts to 0.236 tons, is transported from Concord to Berkeley, which results in 0.236 times 32 kilometers times the emission factor, which is 0.12631, which is 0.94 kg of CO2. And this is one way. So when we do the round trip, we multiply that by 2, which converts that into 1.9. So the total carbon footprint for one resident in Berkeley receiving the New York Times for 1 year is 788 kg of CO2 equivalent, which is comprising of the manufacturing, distribution, and the paper manufacturing, distribution, and the printing of manufacturing. So even in this unique application, you can find as simple as a thing as my buying newspapers, I'm able to find with assumptions what is the effect on the environment. All right? Okay, let's now switch attention to LCA. There was a brief, we saw a lot about LCA with respect to the renewable energy yesterday, and I would like to talk about other applications of LCA as well. If you look at the global level, the estimate is that the Earth can support about 13.4 billion people. And when we look at the statistics here from 2007, with this annual growth rate happening like this, the world right now is about 6.7, around about 2007, very close, and 1.24% it's growing, had grown in that 7-year time period. And in terms of energy consumption, no surprises, US is the top, industrialized countries is 7.5 kilowatt hour per person, Denmark is a little less, but the developing countries is only 1 kilowatt hour per person, okay? So industry is looking for ways to, so being green is trendy, what does the science say? So this is the LCA applications for product design and manufacturing and so on. It's looking for ways to green their products and manufacturing processes. Individuals and families are looking to green their homes, as we saw in the newspaper example, and lifestyles. So how can you tell if something really is green? What is currently happening to achieve this goal? And the answer is that the scientists perform the LCA exercise to do that. So the definition of that is the compilation and evaluation of all the inputs and outputs and the potential environmental impact on product systems throughout the life cycle, okay? So ISO again sets a standard for how an LCA process can be done, and as the guest speaker of yesterday also said, that you can do it with these units of analysis: product development, project development, strategic planning, public policy making, and for marketing and eco-labeling and eco-declarations. Okay, I think this is, I'll be sharing my slides with you today. I think this is an important slide for you to think about. You remember I was telling you that process mapping. Now we have a greenhouse gas protocol and so on, right? It will be interesting to map a product, the manufacturing of a product with this viewpoint by look at the bottom of this. You can look at the loops which are open loops and closed loops, which parts are being reused, which parts are being remanufactured and so on. So you start from the first. M&E stands for material and energy inputs to process and to distribute. W stands for waste, either gas, liquid or solid output from either product, process or distribution. And this is the process flow which is being mapped. So the process flow is not anything new. Raw materials, they're processed, they're sent to the manufacturing and assembly plant. There's a usage in the service, retirement and recovery, and treatment disposal. But what is unique based on your company is if you can see open loop recycle or if there is a closed loop going on in terms of reuse manufacturing. A very important chart for you to mimic in the projects that you're doing. With the combination of greenhouse gas protocol and this, I think you can do wonders on that. It's supply chain too. If I want to complicate this even more, I add another block, which is the suppliers over there. Then I get a supply chain. Right? Makes sense? So what makes up LCA? Goal and scope definition. What is the purpose for which you're doing your LCA? Who is the audience? Inventory analysis. So asking a series of these questions. What is the function What's the functional unit? What are the boundaries? Where are the boundaries? Where are you going to stop the boundaries of your LCA? What data do you need? What assumptions are you making? Are there any limitations to your inventory analysis? Then we looked at the impact analysis, life cycle impact analysis. What are the environmental, social, and economic effects? I think if you remember last time, the guest speaker was saying you need to get all these 3 boxes to be compliant before you can start that, okay? And then what is interpretation? This is the most creative part of it. So in the creative part of it, you're going to look for ways to reduce environmental impacts. What can you draw from study, and what recommendations can be made? So I want to give you a couple of examples. So you look at a simple project when you compare 2 types of pencils, wooden pencil and mechanical pencil. By the way, another process diagram. Okay, okay. So you have a legend, wooden, mainly there's transportation going on. Okay, so for the wooden pencil, you know, the wood comes from the lumber forest, goes to the lumber mill, then other things are added to make the manufacturing process: rubber, graphite, packaging, glass. So you make it, sold to the retailer, you and I use it. We also consume electricity by sharpening the pencil, right? And then there's end of life, probably ends up in the landfill. Compare this with mechanical pencils. Now we have plastic materials. So we need polyethylene, we need polypropylene, both materials of plastic polymers, large molecules used to make many products. So obviously these polymers, the starting point is oil, right? So oil gets into the making of the polymers. Then we have all these component parts: rubber, graphite, packaging, and the spring mechanism for the pencil. To manufacture that, the rest of the supply chain is the same: retailer, use, and end of life. So when I compare these two from an LCA point of view, I can ask these questions. What is the function? What's the functional unit? The function is the service provided by the system, what it does. Functional unit, it gives the function a numerical value. So allows comparison between products and serves as a reference point. So for example, in our example, the function is writing, and the functional unit is 1 meter of writing. Okay? So that's the second step. So what are the inputs and outputs? What is needed to make the substance? And when we saw the process chart, it was energy, materials, labor. Okay? Outputs, what came out of the system, were products, which were electricity, materials, goods, services, waste, emissions, and if possible, co-products. Data collection. Time sensitive, life cycle. So you're going to look at the past 5 years. Geographic, does it match the location from the goal? Technology, what is technology for the process? Representativeness, does it reflect the population of interest? Consistency, does it match the procedure? And can you reproduce the process? If I went and asked you to do the same thing, would I come up with the same outcome? Precision is important. The consistent reproducibility of a measurement is important, and it should cover all the areas that you outlined in the scope, right? Another example. If you think about paper plate versus, what I mean by China is a plate that you wash and reuse, okay? So I can do an LCA action in that by asking the question, what is the function? Same thing between the mechanical and the, the wooden pencil. What is the function? What is the functional unit? What materials and resources are used? What does it take to produce both? What are the impacts on the environment? Is there waste? Does washing the plate also produce? What types of data do you need? And how do you know which is better? Questions. So LCA in action through a series of questions. Okay. Now, a few more things which are kind of the latest technology out there, which I want to point out. We'd all talked about the global warming potential. We have beaten that to death. A thing called abiotic depletion. This is new. So what we're trying to do is that we're looking at the consumption of non-living resources as being a seamless. As a result of working with energy, we ended up, consuming a lot of the non-living resources, and we are trying to see if there is a degradation of that as well. And then human toxicity potential, that is also of interest. Value that shows that harms to humans from chemicals, and how much is needed. A lot of the examples are saying, between, I think somebody asked last time about wind versus solar, how much acreage of land which is needed. That is also being asked in terms of questions. Other new things is eutrophication. A lot of, in fact, as a reminder, I was telling Professor Kilbarton, I brought a set of books from the US to hand to this institution. And there's one particular book which I hinted earlier on, which is related to your Herman Miller case called Cradle to Cradle. It's a must-read book. Okay, I brought one copy, I'll leave it here. Please take turns to read the book. Because there are a lot of these examples of biotic interventions to convert, potentially what would be waste into potential food or nutrients into other ecosystems. So increase in the chemical nutrients containing nitrogen or phosphorus, land or water, overgrowth of plants, killing organisms at the bottom of the water, and infusion of mercury into the ecosystem, and acidification, greenhouse acid rain, smog, and so on. These are all the environmental impact categories that you can study. Where do we go from here? What is the purpose of all this data? Scientists can make recommendations of choices that are less impactful, and they're getting very creative in terms of balancing what could be waste degradation, reuse, and also bringing biotic organisms to have a perpetual recycling loop of that. You can analyze a particular impact and focus on a solution, and industry and individuals can take a closer look at how they can make a difference. So we've come full circle. We covered so many tools today. Started with TCO. We looked at greenhouse gas effect from the individual and from a consumer point of view. We looked at ISO 14001, and we saw LCA as well. Okay. I promised you one more project presentation which I want to show you. Okay. They were color coded: green, red, and yellow. Here, green is low risk to IR, and red is the higher risk. So a composite score was developed to come up with this color code. So I'll show you the costing tool. The costing tool has this work tabs: user instructions, inputs, multiple client sheets, cost summary. Incoterms is the terms of contracts. Okay? And supplier risk assessment key, technical maintenance of this tool, and glossary of terms. As you can see, this is the first tab, the user instructions. Okay? Then we have the inputs, then we have a set of manufacturing plant locations. Okay? Then we have the total cost summary, Incoterms, and so on. This first tab tells the user what data they need to input. Okay? And gives you the instructions of which worksheet they have to input their values. So for example, similar to the wire space, component information, the description, component number, whether it's commodity or not, and you see annual demand. Annual demand is the key input to that. Second thing is the physical characteristics of the component, which is weight, length, height, and so on. Then the details of the container. Are they going to be shipped in 40-foot containers, 50-foot containers, and so on? What is the maximum weight and load? How many items per container, and how many containers do they need in a year? Then come the safety stock and all that calculations, annual demand, weekly demand, standard deviation demand. What is the desired fill rate? We didn't talk about fill rate in the wireless. Design capacity and cost of capital, which we did talk about in the movies. Okay. So the next input is what I talked to you about. Now look at the spreadsheet over here. This is just for one plant. Okay. For this one plant, we're looking at the different suppliers who are coming all over the world: Shanghai, Charleston, Mumbai, Antwerp, Tacoma, and Mexico. Okay. And it goes through the sequence I told you: direct cost, transaction cost, and supplemental cost. So for each of these plant locations, we have a summary with the breakdown of all the things I indicated: direct, supplemental, transaction, and financial considerations, including foreign exchange, which we didn't talk about in the bioharmonics case. Okay? And then the supplier risk assessment, which is to the bottom of that. Okay? So I'll show you the summary sheet over here. So the total cost of acquisition was there on per unit and total per year, just like by this, is summed up for all the worksheets onto a summary. And what they do with this is to come up with the total cost of summary. They did condition formatting in the Excel thing. So if I change any data, the color of the cell will change from yellow to red or yellow to green and so on. So for each of the plants, now we treated cost separate and treated risk separate. Okay? For each of the plants, they found the lowest cost supplier. So for the Fargo plant, the one in Mexico was the lowest cost. For Charlotte, it was the one in Dubai, and for Prague, it was the one in Antwerp and so on. Right? And if you look at risk, the least risky one was Charleston for the Fargo plant. So this illustrates a principle in plant selection called the crisscross effect. So from a TCO point of view, it's not easy to make a choice because for each plant we are getting conflicting results. Look at Fargo, cost alone, they say Mexico with the risk Charleston. For Charlotte, cost alone Mumbai with the risk is Charleston. The Prague is the only one where it gives a consistent result. Okay, it is both cost and risk says Antwerp. All right, and for the Shanghai one also is consistent, it gives the same result. But if you give a mixed result, then it gives a crisscross effect, which means you have to give weights. You give weights to whether cost is important or risk is important. Okay, Incoterms. This is something you should know. I can explain this by looking at the extremes of this. Okay. Remember, I drew that supply chain chart for you from China for the wire harness case coming up with the customer. Right? These are all the activities which are happening for the typical supply. Warehouse storage, labor, export packing, loading charge, inland freight, terminal charges at the port, and so on up to the destination. If you look at the first column, which is a contract called X works or X plant, what you see is there is a shift in responsibility of risk very quickly from the supplier to the company. After 3 stages, it is quickly shifted to the company, which means from step 6 to 14, the company is in charge. The supplier liability is only up to step 1, 2, 3. You look at the other issue. If I look at this DDP, which is delivered duty paid, the supplier has responsibility for all of those 15 steps, 14 steps from the start to the finish. So you as a company can choose how you want to optimize your risk liability accountability by setting the contractual terms. That's called Incoterms. Okay, risk assessment key. Everything has a legend, what we mean by NAFTA compliance and how they color coded. Okay, now brings me to another important principle. In terms of metrics, how we measure stuff. There is a continuum that when I don't know anything about a metric, I tend to measure them in dichotomous variables. Dichotomous variables means yes or no, or 0 or no. So for instance, do you have an environmental management system in place? Are you ISO 14001 certified? But once I know, this does not capture the quality of implementation. So once I know a little bit more about that phenomenon, I can start to capture that in Likert scales. So I can say, how good was your implementation on the scale of 1 to 5, or 1 being poor and 5 being good? Or my favorite, because managers tend to think in terms of percentages. When running say about 1 to 5, I can convert that into percentages. So 1 to 100%. Not only the quality of implementation, but the quality of implementation, right? So we go from dichotomous to Likert scale, and after that, the most ideal one would be continuous, objective. So if the data is of high enough quality, then data does not lie. So that will give you a more consistent picture of the metric that you are having So the idea is to get metrics which is as objective as possible and least subjective as possible. So in every metric system, you want to look at data items which are measured with a high degree of quantitative numbers. It varies from company. In the handout, it tells you even things like greenhouse gases outstanding, or all measured carbon footprints outstanding. So this glossary of terms tells how the company defines each one. Is it clear? Is it clear? Okay. So the beauty of this is that in one semester course, a team of MBA students, along with the input of the company, and of course I have learned, we got them a simple tool to work on worldwide TCO computation, and they implemented it. And we infused all kinds of new innovations in terms of spreadsheet design, how to collect data, how to think about it. Okay, let me stop here and ask if you have any questions or comments. Anything covered?
Who framed this GST?
GHP.
Who framed that?
Oh, it was mentioned in the handout. It was part of that, some disclosure thing. So it was a global non-profit.
For example, if it is
It's a non-profit company.
it is an origin from USA, whether the US government is ready to adopt a protocol.
That's actually a good question. So right now everything is voluntary. People have said this is one methodology. It is gaining a lot of acceptance. Maybe who knows, tomorrow there may be another protocol which is put into place. But it's not mandatory. It's not only the way. Have you already started?
For us, actually, our team went and saw industry only by today. And
Yeah.
we need to check some more by today evening as well.
Okay, the short answer to your question is if you think it will be ready by tomorrow, then you can present it. Okay? But if you need more time, then you don't have to present it. Okay? I am mainly interested in things like what has been done so far. In fact, let's take a minute. What we need over here is process mapping with environmental metrics. Alright, there's one example from today's presentation about this supply chain and process mapping, right? Before which, what do they currently do as is? This is called as is. And once you make your recommendations and changing the process, what is the future process going to be? Okay? And for this you're going to make recommendations and key lessons learned. So recommendations is more for the client. Like when I want to go back to the company and say, okay, this is what I would recommend that you do for the managers. The key lessons learned are for us. That we should incorporate the course material and say, this is what we learned from the course. So you're looking at course concepts. Okay? So this is very broadly the outline of what I'm thinking about. But from the implementation point of view to tomorrow, I want you to cover what has been done, what you plan to do, with maybe some timelines, and if possible, what you expect to find. Okay? So, maybe you can take your cell phone, it's easy for you to do. I've given you an outline of what the project
what should look like, but also your proposal presentation. To the extent that you may have enough information for the campaign context, maybe you have isolated technical problem. What tools you're going to use is already known, probably the greenhouse gas protocol. Recommendations and challenges will come later on. You may not be able to get this tomorrow. And then cover the project implementation plan. What have you done so far? What are you currently doing? What is that?